For this question, it states a compound contains 25.94% nitrogen and 74.06% oxygen. What is the empirical formula? You want to assume that you're working with 100% of the compound. This allows us to set nitrogen at 25.94 grams and oxygen at 74.06 grams. Now that we've converted the percent by mass to grams, we're going to convert the grams to moles using the molar mass from the periodic table. And looking at the periodic table, we see that for every mole of nitrogen, there are 14.007 grams. Grams are put at the bottom so that we can cancel out grams and leave moles, which gives 1.8519 moles of nitrogen. Doing the same for oxygen, we have 15.999 grams in every 1 mole. Again, I'm putting grams at the bottom so I can cancel out and leave moles, which will give us 4.6290 moles of oxygen. The next step is to find the number of moles that has the least. In this case, it's nitrogen. And you want to divide every element in the compound by the number of the least amount of moles. So in this case, we're going to divide nitrogen by 1.8519 and oxygen by 1.8519. 1.8519 divided by 1.8519 will give us 1. And 4.6290 divided by 1.8519 will give about 2.5. Now the goal is to get these numbers to be as close to whole numbers as possible because these are going to become your subscripts. And in the cases where it rounds to a 0.5, you want to multiply this 2.5 by 2 in order to get rid of the 0.5 and obtain a whole number. 2.5 times 2 equals 5. But if you do it to one element, you have to do it to all elements, meaning since I multiply oxygen by 2, I'm going to have to multiply nitrogen by 2, which will give us 2. These will now become the subscript in our empirical formula. So in this case, nitrogen 2, oxygen 5. N2O5 is the empirical formula for this compound. As always, thank you for watching.